Okay, let's dive into this. Welcome to today's Explainer, where we're going to look at the invisible engineering that is quite literally holding our sleek modern devices together. If you've ever found yourself wondering exactly how manufacturers achieve those incredibly thin device designs without using, say, bulky screws or snapping clips, well, you are definitely in the right place. Today, we're decoding the 3M Plastic Bonding Adhesive 2665.
So here's our game plan for today. We'll start off with the plastic bonding challenge, evaluate the adhesive itself, walk through an application masterclass, cover handling and safety, and wrap it all up with the final bond. Let's get right to it. All right, Section 1, the plastic bonding challenge, or as I personally like to call it, modern manufacturing headaches. To really set the stage here, ask yourself this. How do incredibly thin gadgets, like the smartphone in your pocket or that super slim portable battery, how do they survive intense drop tests without shattering into a million pieces? And they do it without relying on heavy, space-consuming metal screws. Look, manufacturers are constantly chasing lightweighting requirements and these crazy complex geometries. And let's be honest, traditional fasteners just don't cut it anymore. And this comparison brilliantly illustrates exactly why. Think about traditional methods for a second. You've got riveting and welding. Riveting creates a localized bearing load stress. Basically, all of that physical stress is concentrated at a single tiny rivet point, which, as we know, cracks plastics. Plus, you've got rust risks if you're dealing with metal substrates. Now, flip over to the 3M 2665 adhesive. This moisture-curing urethane creates these incredibly thin, flexible bond lines. So instead of concentrating force, it distributes that bearing load evenly across the entire substrate. It basically acts as a flexible, high-strength hero for delicate device housings. So it sounds like a silver bullet, right? Well, let's move to Section 2 and objectively evaluate this adhesive, looking at both its really powerful advantages and, of course, its operational realities. Now, what's really interesting here is the unique balance of properties. On the advantage side, this stuff is a 100% solids one-component formulation. That is huge because it means no volatile organic compounds to worry about drying and no messy, inconsistent mixing of two different parts. It dispenses hot, but it gives you a pressure-sensitive adhesive, a PSA-like tack for immediate handling. And, crucially, it is reworkable after curing. Meaning, if you mess up an expensive touch display module on the line, you can actually use a debonding machine to recover it. It's a total game changer. But, looking at the disadvantages, you have to be prepared. It demands highly specific equipment. You absolutely must have heating equipment capable of reaching 110 degrees Celsius, which is 230 degrees Fahrenheit. It also has a really short open time and presents some significant handling and toxicity risks, which we're definitely going to cover shortly. But before you go and specify this for a new build, you really need to know what it actually sticks to. It is excellent for hard-to-bond plastics like polycarbonate, ABS, acrylic, and PVC. However, there is a major warning here. The 3M 2665 is expressly not recommended for untreated polyolefins, so keep that in the back of your mind when you're selecting your housing materials. All right, Section 3, Application Masterclass. When you're actually using this stuff on the assembly line, it is very much a race against time. Let's walk through the precise step-by-step life cycle of the bond. Step 1, and this is non-negotiable, surface prep. Clean the plastic with isopropyl alcohol, or MEK if you're using metals, and let that solvent fully evaporate. Step 2, you must heat the 30 cc syringe for a minimum of 30 minutes at 110 degrees Celsius. Step 3, dispense the molten adhesive using either a time pressure dispenser or a positive displacement gear valve so you can get those super thin, perfect lines. Step 4, join the parts immediately. And finally, Step 5 is the cleanup. You want to let the product solidify and then remove the uncured waxy material by scraping it with a putty knife. You usually do this within the first 20 minutes after application. And a quick pro tip, never ever use heat or flame to clean it up. Now, I really want to pause on this number, 4. 4 minutes is the absolute maximum open time you have. The clock literally starts ticking the second that 110-degree molten adhesive hits the room temperature substrate. Between 1.5 and 4 minutes, that adhesive is actively solidifying. You have to join those substrates before that window closes, or you completely compromise the structural integrity of the bond. No pressure, right? And because of those extreme temperatures and chemical properties, Section 4 is absolutely critical. Let's talk about handling and safety guidelines. You'll recognize this health hazard icon directly from the product's safety data sheet, and it is a stark reminder.
The crucial point is that this moisture-curing urethane carries serious warnings. Prolonged or repeated exposure can cause damage to organs, specifically the respiratory system. It can also cause skin sensitization and some pretty nasty allergic reactions. So adequate ventilation, absolutely not breathing the fumes, and wearing proper chemical-resistant PPE are non-negotiable requirements.
Beyond just the chemical hazards, we have some strict thermal and equipment rules you've got to follow. First off, if you use pneumatic dispensing, you have to use dry air to prevent the moisture-curing adhesive from prematurely hardening right inside the equipment. Second, 110 degrees Celsius will cause severe thermal burns, so heavy thermal gloves are absolutely mandatory. Third, if the syringe starts inexplicably dripping, don't panic. It's often just because a cured adhesive skin has formed at the back of the syringe. You just need to carefully probe and break that seal. And finally, there is a very specific rule about the packaging itself that surprises a lot of people.
Do not remove the aluminum label from the syringe. I know, it's super tempting for assembly workers to peel off product labels just out of habit, but this aluminum label isn't just for branding. It is literally a vital piece of thermal engineering. It's designed to make the heat distribution across the syringe completely uniform while it sits in the heater. If you peel it off, you get uneven melting, and I guarantee your adhesive will not dispense properly, so leave the sticker on. Which brings us to our final section, the final bond. Look, we've seen how this 3M2665 moisture-curing adhesive completely changes the physical constraints of manufacturing by replacing heavy screws, eliminating rust, preventing those terrible stress fractures from brittle welds, and maybe best of all, allowing expensive parts to be reworked rather than just thrown in the trash. It unlocks entirely new form factors. The structural limitations of the past are melting away, literally. So, armed with this kind of invisible engineering in your toolkit, what impossible device will you design next? Thanks so much for joining me on this explainer, and I can't wait to dive into our next topic together.